Okay, well, so when we're solving systems of linear equations, we're looking at two lines and we want to see where they cross. And so here's one from a different book. I'm not going to do the ones that are in the quiz or in the exercises. I think I can do it just as easily here. Okay, so what I'm seeing is, so there's a couple of ways to do it. I'm going to show you both ways. See how this first equation is already in y equals mx plus b form? So that's pretty easy because we know the slope is negative 2/3 and we know the y-intercept is the b, right? And so we know that crosses the y-axis at 0, 1. Now, it'd be really nice if the other equation was that same form, so what we can do is I'm going to solve for y equals. So I'm going to subtract 2x from both sides, and I'm sorry I don't have room really to do that here. So that what leaves me is 3y on the top equals negative 2x plus 6. See, I just moved that 2x over by changing the sign, right? Then we divide by 3, divide by 3, divide by 3. Both sides of this equation needs to get divided by 3. So I could put this all over 1, 3, but then that's kind of hard to see. So I usually write it this way. So 3y divided by 3 is just y. Then I got negative 2/3 x plus 6 divided by 3 is 2. So now that's in y equals mx plus b form, where the slope is 2/3, so negative 2/3, and the y-intercept for this one is 0, 2. Then we just got to graph both of these, and then we'll look for the intersection. So I'm going to make an xy axis. I'm going to change some ink here, I think, to red. So I'll graph this one in red. So 0, 1 is where it starts. That's a y-intercept. We begin here, right? And then we're going to go down. Oh, seriously? Is that really what's happening? Well, that's good. I didn't mean to do this, but this is a good one to do. Okay, so I'm going to go down 2 over 3, down 2 over 3, down 2. I'm out of space that way, so I'm going to go up 2, left 3, so I keep it on that same line. Up 2, left 3, and then I kind of just sketch it as best I can. Then I'm going to graph the other one. Well, that crosses at positive 2, and that also goes down 2 over 3, down 2 over 3. I didn't do something right here. Just a minute. I messed that one up. Let's see, yes, it starts there, crosses there. Let me undo what I just did. Undo it, undo it. Undo it. There we go. Then I'm going to go down 2 over 3. Whoops, not erasing, Dan. I want to use a pen. And I'll use green. Down 2 over 3, down 2 over 3, down 2, and I'm out of room. So do you see how what I'm trying to get you to see out of this is it's actually a parallel line. And those points will never cross. Those lines will never cross. So when the lines are the parallel, they don't have a solution. And I should have been a little more with it when I did this, but you see how the slopes are the same? So that's a flag that they're parallel lines. So if I hadn't been quite so asleep, I would have noticed that. Okay, so sometimes it's good to put them in y equals mx plus b form, so you can just notice the slopes. If the slopes are the same, they're never going to intersect. So there's no solution here because they're parallel. They'll never intersect. Okay, hopefully the next one I pick won't have that happen. Okay, so for this problem, neither one of these equations is solved for y. So we'll do it. I'll show you two ways to do this problem. So what I'm going to do, first one, I'm going to subtract x from both sides, right? That leaves me y equals negative x plus 1. Now I'm writing it in mx plus b form. So that tells me the slope, m, is negative 1, and the y-intercept is the 0.01. Now this other one, I'm going to subtract. It's a little different. I've got to subtract the 3x from both sides, but I've got the negative 1y. That stays there. We don't want to lose that negative. Minus 3x minus 5, and then I'm going to divide by negative 1, which means change the signs. So y equals 3x plus 5. So that has a slope of 3 over 1 and a y-intercept of 0, 5. So let's graph this. Let's get a graph paper going here. So I'm going to start at positive 1 here. Let me get a different color ink. I'm going to start at positive 1 and then go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. I'm going to go backwards too, up 1 left, up 1 left. So it looks something like this. I don't know if I've got the intersection point graph, but we'll play around with that. Now for the other one, I start at positive 5. 1, 2, here, let me go to a blue ink. 1, 2, 3, 4, 5. And then it has a slope of 3, so I'm going to go up 3, right 1. But you see I'm going away from the line. So I'm going to go backwards. Instead of going up and right, I'm going to go down and left. And lo and behold, look at that. 1, 2, 3 over 1. So there's the intersection point. It looks like negative 1, 2. Then what we should do to make sure we're correct is take those and substitute them back in to the original equations to make sure they work in both of them. So what did I just say? Negative 1, 2. So if x is negative 1, y equals 2, and the first equation is take x plus y, that has to equal 1. Well, it does, because 2 minus 1 is 1. Then for the other one, 3 times negative 1 minus 2, is that equal to negative 5? Well, that's negative 3 minus 2 more is equal to negative 5. So because my point that it looks like graphically it's the solution, it checks in both of them. So I know I didn't mess up. Okay, so there's that way to do it. Now sometimes it's easier not to put them in MXB form, and we can graph it using the intercept method. Now I don't remember if the Algebra 2 course shows this method, but for each of these equations, if I can find out where does it cross the x-axis, so if it crosses the x-axis, y equals 0, doesn't it? So if I go back to this first equation, I say y equals 0, does that tell me x equals 1? Because x plus 0 equals 1, so y has to be 1. And then for the other one, for the y-intercept, x is 0. If x equals 0, y equals 1. So that tells me this graph crosses at those two axis points. Then the other one, right, if y is 0, x is going to be, so I've got 3x equals negative 5, so that tells me x is negative 5/3 or negative 1 2/3. Not a very pretty number, so I'm not convinced this might be the easiest way, if this is the easiest way to do it, but sometimes it works easier. We'll get the right answer, it's going to be a little bit different. And then if I'm looking for the y-intercept, x is 0, that leaves me negative y equals negative 5, so does that tell me y equals 5? Then to graph it to get the solution here, let me get a xy axis going here. We already know the answer because I just did this by the mx plus b form. So this blue graph crosses at here and at here. So there's that line here. The other one crosses at negative 1 2/3, so right about there. And at 0, 5, so 1, 2, 3, 4, 5. Now if we draw those lines, see how it crosses that nice lattice point, that negative 1, 2, and of course we already checked that, so I don't know if that's easier than the other method, but it's a way that works. So one last thing they're going to ask you in the homework quiz for this in particular, though they go over it in the lesson. They give you a graph. They show you the intersection. Great. This one doesn't have a very nice intersection, but it's there. And they say what system solves it. So what they aren't telling you the equations. So we can kind of get this. We can see the red equation has a y-intercept of 1, and then it has a slope of up 3 over 1, up 3 over 1. So we know it's y equals 3x plus 1 because of the y-intercept. And the blue line has a y-intercept of what? -4. And it has a slope of, let's see, up 1, 2, 3, 4, 5, 6 over 1. So the blue line, whoops, let me get blue going here, is 6x minus 4, right? And we could graph those, and they did, and start with the intersect. But what they asked you on the homework quiz is this. This point, aren't the x's and the y's the same at that point? So couldn't we set those equations equal? They're both equal to y. So couldn't I say 3x plus 1 equals 6x minus 4? And that would be a system that's this system, we're solving it for x, and then we could go back and find y. But this is what they're asking you to do, is both equations have been solved for y and set them equal. And they just give that from the graph, okay? So what you got to do is look at the graph, come up with the slope and the y-intercept for each line, and just set them equal to that. So hopefully that helps. Hopefully that gives you enough help on how to do this section. Let me know if you need some more.